incorporating risk-based planning decisions using current climate data. Also, how effective are our systems? Right now, we only use a long-term average erosion. So how effective are those systems during drought and heavy rainfall years? In this example, I have three different management options, if you will. One with the soil health management system, the second with more of a conservation tillage system, and the last one with a conventional system. And we can simply apply the common management that's used on these using the modal concept for this site. In this example, I'm using a cropland state and different management options within it. So what questions can we answer within state and transition models? We can use for the management options in this example, conventional tillage and the different practices that are being applied. And we can answer three basic questions that planners could use. One is, what are the on-site indicators? And you see here, there's some obvious on-site indicators. And what range of dynamic properties might be present in the within each different management option? What are the limitations for this land use? And what practices and management offer the most resilience for drought or severe storms? Here's three photos I took of the same ecological site on nearby farms back in 2018. And this is an example of how planners could use on-site information. The first one is a soil health management system with good rotation and IPM. The second is more of a conservation tillage system with some issues with kochia weed resistance. And last one is a conventional tillage system that has low resilience. The three basic things we can identify as an on-site planner would be what are the physical, chemical, biological indicators or soil health assessment, if you will? What ranges of soil properties might we expect on each different condition? The transitions and practices, how can we move from one situation to the other? Also, what are the resource impacts of applying these three different systems in this example, the photos that I took? This is from my own farm and kind of show you the importance to farmers of some of these concepts. Here you see on the top is yields for corn, soybeans, and wheat for the last 10 years, what the county averages are. Specifically in 2012, we had basically a 100-year drought, hailstorms, those types of things. So you can see how yield is impacted. Second part of this is I pulled the rainfall data from a state climate station within 3 miles of my farm. And you can see the high variability. And so what we want to do with our conservation planning and systems is offset some of this variability. In the blue, you see the rainfall that occurred the last 10 years during the primary part of the growing season from May through basically September 1st. What occurred during the off season in moisture and what occurred during the yearly rainfall. Also within some of these individual years, there were at least two 5-inch rainfall events. So the idea of assessing risk is to look at this type of variability that's becoming more commonplace. Here's what our current erosion models would give us in this example. For example, Russell 2, which is an empirical model, could give us long-term average, long-term runoff, and soil conditioning index. With the process-based models, not only can we get for these different management options, the long-term, but we can project over a 100-year period. What happens during drought years? What happens during those high rainfall event years? This is from WEPS. This is the current WEPS model, what we can get out of it. That's for wind erosion. You can see the gross soil loss in this site is 3.1 tons. The soil loss or T tolerance is only 2 tons. But you can see we can break down into crop intervals. In 1 year, we're as high as 9 tons of long-term average annual erosion. Here you see also within WEPs currently, we can generate what's called confidence intervals. And here you see an insert of that. So in the green area, predict from a 50-year WEPs predicts 50 years for each crop cycle. And here you see the 90% confidence of what the actual erosion would be. You can see there's quite a bit of variability. If we simply use the average on the red line, that doesn't really tell me much about the risk. That's the importance of it. Also, you see the cycle average, depending on the crops and the residue levels and the particular weather we get in each simulation period, what the cycles are. We can provide confidence interval reports currently. This is again through WEPS, the wind erosion prediction system. And here we can plot out what the expected extreme outlier erosion would be, what the mean, what the median is. And so again, in many parts of the northern plains from Montana through northwestern Minnesota, this is what we've seen, some of these outlier events. So the power of these models is we can actually predict what would happen during these extreme years. Here's an example for a cycle run through WEPS. You can see anywhere from almost no erosion through 19 cycles up to 16 tons. And then within each of those cycles, we can also look at what the average, the low, and the high was. So again, that's the power of process models. In WEP, we're currently working with ARS on WEP, a water erosion prediction system. And currently we can get mean, median, standard deviation, coefficient of variation for our erosion, our sediment delivery, for what's happening to our water. So you can see here also over 100-year simulation period from a very droughty year to maximum year, what you can get. For example, evaporation can be as high as 15 inches in that extreme drought year. So this again gives you that type of information. Some of the things that we're looking at is within, in this case, a corn soybean rotation, where we can look at, again, the extreme erosion rates for each crop year. In this example is over a 100-year period. So you see in one example of the soil loss tolerance of T in the red line versus average or annual erosion is below T. It all looks good, right? But then when you look at the individual crops in extreme years, that's not so good. So that's the power again of using process models. Here are some proposals that we're working on for both actually WEP and WEP risk statistics, single page reports, where we can look at the number of years beyond T, the percentage of years, what's happening to your water. We can also bring irrigation into play on how much irrigation may be needed in drought versus normal versus extreme rainfall years. Here's some graph statistics. Again, we could run these on an ecological site, modal concept, rainfall and irrigation in a very dry year versus the wettest year, and then at what's average. So again, how much rainfall. Also, what happens to the fate of our water from deep perk water to soil evap to plant transpiration and runoff in that driest year versus the wettest year versus average. So again, we can see how effective our systems are in those wet and dry years. Here's another set of statistics that we are proposing for the new WEP and WEP's statistical reports. One would be what's the expected average annual erosion is in circle. So in our WQ and Russell models, that's what we get is just long-term average. With this process models, we could predict 10-year, 25-year, 50-year erosion rates. Is that acceptable to a farmer? Probably not. And then you can get the maximum and minimum erosion rates over that 100-year prediction period. Also, you can see, again, not only erosion extremes, but how often do we exceed that T threshold and what percentage of years. So a lot of power and information to see how effective our planning and systems are. In summary, we can use state and for cropland, we can use common management options, resource conditions, and expected outcomes, not only in average, but long-term extreme years, drought and high rainfall years. We can use it for risk-based decision making. We can also use current climate data and assess the risk of severe weather and extremes, and the ability to evaluate the effectiveness of common conservation systems during average wet and dry years. So thanks for your time and attention. I look forward to any questions that you might have.